I want to welcome you to this lesson. This lesson, we are basically going to look at what they call conjugate points. Sometimes they call it, sometimes it is called conjugate foci or foci. Okay? So we shall say that these are pairs of points along the principal axis of a lens such that an object pressed at one, gives rise to a real image at the other. So what does that mean? It means that if we have a diagram like this, let's have a small diagram here. This is a lens, and then we have this one here. This is I, so this is O, this is I. Then we shall say that if object O gives rise to what? If the object O gives rise to an image I, then if the points are interchanged, then the image will be formed at O. So meaning that if this and this are interchanged, if object is brought here, okay, then the image is formed here. Okay? So these are what we are calling them. This one we say they are conjugate points. They are points along the principal axis such that an object pressed at one of them gives rise to a real image at the other point. Is that clear? Yes. So supposing a convex lens forms, better this one is like we normally use a convex lens. Suppose a convex lens forms an image of object O. This one here. Okay? If the object was pressed at I, if the object is pressed at I, then the lens would form the image of the object at what? At O. So we shall say that O and I are conjugate points. Points. Then we shall say, consider an object pressed at a distance x from principal focus F. Principal focus what? F. Let's do this diagram. We have this diagram here. We have this diagram. So this is F. This is also F. So the object is placed here at a distance. This is X. Let us say this is F, of course. Then image is formed here. Image is formed here at a distance. Let us call distance y. Okay? Distance y. Then this distance we shall call it what? That distance is focal length. Therefore, we shall go ahead and say using using 1 over f equals 1 over u plus 1 over v. So our u becomes what? Our u is equal to x plus f. Then our v will become the image distance is f plus y. So we substitute. So 1 over f will now become 1 over x plus f plus 1 over f plus what? Y. So LCM is x plus f into f plus what? Y. So when we substitute, this becomes f plus y. Okay? Then here we shall have plus x plus f. This one gives us 1 over f. So the 1 over f will now become, this is 2f plus 2 plus y plus x divided by, open brackets, this is xf. This and this, that's the plus xy. This and this, that's plus f squared. This and this plus what? Plus fy. Cross multiply, we shall have 2f squared. Okay? Plus fy plus fx, giving us xf plus xy, okay, plus f squared plus fy. So you realize that this one will cancel with this. Then this one will also cancel with that. Okay? So going to take time, this one comes here, we shall get f squared is equal to xy. So our f will now become square root of xy. Then we shall now say that this is Newton's equation. This is Newton's what? Newton's equation. This is Newton's equation. This is Newton's what? Proceed. This is Newton's what? Equation. So we go to displacement of a lens. Displacement of what? Of a lens. When all object and screen are what? Are fixed. So we're going to just have the object, the screen, they are fixed. So we're going to displace the lens through, okay, across the distance. So when you displace, when you move the lens from the object, that is when you have illuminated object like a bulb. So when you move the lens, you will see on screen an image which is magnified. Then when you continue moving, the image disappears. And as you are about to approach the screen, as the lens is about to reach the screen, then the image reappears. But this image which will be formed will be diminished, and very what? Clear. You get it? So let us displace the lens. So we shall now say, we have, let me say, this is the principal axis. Then you have the lens. Let's call this lens in position A. This is the lens in position A. Displace it here. Lens now in position B. Then the object is here, and the screen is here. I. So I'm not going to what? To displace the what? The object and the screen. They are going to be fixed. So meaning that this one is going to give us like this. Okay. Then from that. image here, like that. Like that. Both an image where and image there. Now, A is going to be the lens is now displaced to position what? B. So it is displaced position B. It means that A is no longer there. Now we have one lens which is B. So the lens has gone to position B. So the rays will now become this. The rays will be like this. Then in here, the rays will be like this. Position B shall have the rays like that. Then we shall have the rays forming the what? The imaging here on the screen. So it means that we shall now say that since the lens has been displaced and I and O are remaining the same, that means that if I get this I and I put it here, okay, then I bring the screen here. Where the O was, that is exactly where the image will be what? Formed. Therefore, O and I are conjugate what? Points. So the distance here, let us call it D. Okay. Then the distance from here up to here, up to the screen, we call it L. The distance we shall call it what? This distance here, we shall call it L. So we shall say since O and I are conjugate what? Conjugate points. Then it means that you see here, OA is equal to BI. That's one. Then another let us look at the position in what? In here, at B. From O to B, from O to B is the same as A to I. Okay? Then after that, let us look at the lens in position A. In position A. Let's get it from here. In the position A. In the position A, our U is same as OA. Not so? Our U is same as OA. But to get OA, I can get the whole of this distance, which is the OI minus this distance, which is AI. So our OA will not become, this is OI, which is L, minus here. Now, from A to I, we shall say it is AB plus BI. AB plus B what? BI. So OA will become L minus AB plus BI. But BI same as OA. So OA will be equal to L minus, this is D minus OA. So this becomes 2OA. 2OA will not become L minus what? D. That means that our OA will become L minus what? D over 2. This implies that our U will not become L minus D over 2. Then, in position B, in position B. In position B, our V becomes what? Our V is the same as BI. But to get BI, okay, we shall say that it is OA, okay, minus OB. So OA minus O what? OB. But then OB is same as what? So this is O, which implies that here we shall have OA minus OB. But OB is same as OA. So this is OI. This is OI. You understand? This is OI. Yeah? So this will be OB. Now O to B is same as OA plus what? Plus D. OA plus AB. So this will become L minus. This one is we already have OA. We already have OA. What is our OA? Our OA is same as U. Which U is this one? Okay? So we are saying that our V, oh sorry. We made a mistake here. There's some mistake here. Our V is same as, we are still in the position A. V is same as AI, which AI is same as OI minus AI same as OI minus O A minus O A, which will become, this is L minus D over 2, which will become 2L minus D plus D, minus L plus D over 2, which is L plus what? So V will become L plus D over 2. So from there, can you move this diagram now? We no longer want it. We no longer want this diagram. Then we shall now say that 1 over F equals 1 over U plus 1 over V. 1 over F will become, so we substitute 1, this will be 2 over L minus what? D plus, this will be 2 reciprocated plus D. LCM, L minus D, L plus what? Plus D. So we shall have 2 into L plus D plus 2 into L minus what? And this is 1 over what? So this 1 over F will now become, this is 2L plus 2D plus 2L minus 2D divided by L squared minus this squared. Difference of 2 what? 2 squares. So D will cancel. So say 1 over F will now become 4 what? 4L divided by L squared minus D what? Squared. So reciprocate. F will now become L squared minus D squared divided by what? 4. Very important what? Equation. Very important equation. So they can ask you to derive this equation. They can ask you to derive this equation when the lens is displaced through this density, keeping the screen and the objective fixed. Okay? Then the next. So the other one is displacement of the lens. Okay? When the object and elect image are fixed. Okay? When elect object and screen, when elect object and screen are what? Fixed. So here let's have something like this. So this axis first. This axis. So this is the lens in position A. This will be lens in position what? Position B. We have this. The lens in position A, the lens in position what? B. Then we're going to have an object, elect object, this one here. Then we shall have this. Then we shall have this. So what this one does here, this one forms an image somewhere. Let's say if the image form is here. The image formed is here. This is the image which is what? Formed. Let us call it this one I what? I1, and height is H what? H1. Okay? This is H. Then this one here is going to form also from here to here for the second position through the center of the lens. Then don't form the image here. So this one should come like this. Like that, okay? Now, this image formed is I2. Height is H what? H2. Okay? Height is H2. So this is O. So we shall say that this is I, okay? So the same image actually, that is I. So we shall say that since O and I are conjugate what? Conjugating points. Then we shall look at the conjugate. So in position what? In position what? Positioning in position A. So the magnification in A will become, of course, before that, that means that our OA is same as BI. And then our OB is same as AI. Then from here we shall now say in position A, in position what? Position A, magnification in position A will become, remember it's height of image or height of object. So height of image is H1, height of object is H, isn't it? Which is same as the image distance, that is AI over the object distance. Our object distance is OB. Equation what? 1. Then we got what? In position what? In position B. Position what? B. Now in position B, magnification in B will become the image distance. So in here, image distance is BI over the object distance. Our object distance is what? It is OB. Is equal to height of image. The height of image is this. Over height of object, which is that. Over H. But then we know that BI, what is BI? BI is same as OA. So this one is same as OA over OB, giving us H2. But yeah, what is BI? BI is same as OA, and then AI is same as OB. Okay? AI is same as OB. So here we put, okay, AI is same as OB. Is it true? AI is same as OB. That's correct. Then OA is same as BI. So from here, we shall now say BI. Our BI over OB is equal to H2 over H. So what is the difference between, can we make OB the subject of formula? So OB will become H over H2 times BI. So substitute in 1, this is 2, put 2 in 1. So we shall now say that put 2 in 1. So where is it? OB, we shall put this one. So we shall now say H1 over H is equal to that is AI. Okay, divide that H will go up, H times BI. Okay, H times BI. So I think here, when we say that for the case of this, let us go back. Magnification is equal to, this one is okay. Then the distance, image distance is AI. Okay, the object distance is, sorry, here we made a mistake. It is OA. This is OA. OA. We made a mistake. Sorry. OA. So we shall now come here. Oh, we made a mistake here. OA. But then AI is same as OB. AI is same as OB. So I think here we made a mistake. We shall say from, actually from here. We can say therefore, BI, we have said that BI is same as OA. Is that all okay? So this is OA over OB. OB is AI is equal to H2 over H. So with this bracket, that is AI over OA is equal to H over H2. This is the equation 1, 2. So look at 1 and 2, they're equal. 1 is equal to 2. So we shall now have H1 over H is equal to H over H2. Cross multiply, H squared is equal to H1 H. That implies that what? It implies that our H is equal to square root of what? The size of the images. Very important question. This one was set, I think, 2017. Yeah, 2017. That question was, I think, 2017 or 2016 on there. This question was there in section what? Section A. I think the rest is clear. Yeah. Then we shall move on and we look at that this method of measuring H is most useful when the object is inaccessible. For example, when the width of the slit inside the tube is required, or when the focal length of the inaccessible lens is required. So this method is convenient when we are asked to obtain the focal length of inaccessible lens. Inaccessible lens is that lens that you can put in a tube. It is in a tube, so you have no access to it that you can displace it. Instead, what you do, you displace the tube. Okay? You displace the tube as you look at the images formed. There are two cases when the images are going to be formed. When the lens is displaced through the what? The distance along with what? The object and the screen, when both of them are what? Fixed. Then we can also find conditions for a real image to be formed. What are the conditions? We have already seen the object distance must be greater than the focal length of the lens. That's number one. The object distance must be greater than the focal length of the lens. The second condition, we shall say, the distance between the object and the screen must be at least 4 times the focal length of the lens. So those are two what? Conditions. Normally they ask for 3, but I'm so conversant with 2 as per now. That the distance between the object, okay, and the screen must be greater than the focal length of the what? Sorry, the distance between the object and the lens must be greater than the focal length of the lens. That's number 1. Number 2, the distance between the object and the screen must be at least 4 times the focal length of the lens that's going to be using. Should the distance be less than 4 times? Of course, we saw it last time. We saw in one of the deviations that the D should be greater or equal to 4F. Those are the 2 conditions. Whenever they ask you, please always give those 2 conditions. Now, let us look at examples. This is for concerning separated lenses. Separated lenses, or we can say coaxially separated what? Lenses. So here you have like a lens here and another lens here, so that an object is present in one of them. So that one lens forms an image, but that image will act as object for the second lens, and then the second lens forms the final image. So let us look at examples. Like for example, example number 1. We are going to use this one as example number 1. Are you seeing this one? Example number 1. I hope you can read it properly. Example number what? Number 1. Okay. So what does it say? Now, it says 2 thin convex lenses A and B of focal length. So we have 2 thin lenses A and B. A and B. So this is A. This is B. This is just a sketch diagram. We shall draw the final diagram. Two convex lenses A and B. The focal length they have given us 5 centimeters and 15. So F here is 5 centimeters. F here is 15 centimeters. Are placed coaxially 20 centimeters apart. 20 centimeters apart. Like that. 20 centimeters what? Apart. Then, if an object is placed 6 centimeters from A, 6 centimeters, object 6 centimeters from A, on the remote side of what? Of B. The remote side of B, it implies that B has no access to the object. Okay? B has no access to the object. Here they are saying, find the position and nature of find the position, nature and magnification of the final image. So we shall say action of A. Action of A. So this A is got from an image. Let us say image is here. I prime. But the image formed by A will act as object for B, and then B uses it as an object, and then it forms the final image. But as for now, we don't know where the final image will be formed. We don't even know whether it is virtual or it is real. So let us first check the distance here. We call it maybe. Let us call this one V prime. V prime. Okay? V prime. Then to act as object for what? For this one, therefore this will become our U now. You get it? So we shall now see action of A. 1 over F equals 1 over U plus 1 over V. Let us call this one V prime, U prime. So 1 over 5 will become 1 over 6 plus 1 over V prime. So prime that 1 over V prime will become 1 over 5 minus 1 over 6. And also with that, this is 6 minus what? 5. So 1 over V prime, you see that one. So V prime will now become 30 centimeters. So where do you think 30 centimeters is? This is 20 from here, this is 20. So 30 is around this side here. Okay? So this is meaning this is around what? 30. Like that. Then we go to action of B. Action of what? Action of B. So action of B, what is our U now? What will be our U? Our U is from here to here. Is from here to here is 30. And from here to here is 20. What is this distance remaining? So it will become 30 minus 20. But when you look at where it is formed on the other side where the image is supposed to be formed. So an object is always placed in front of the lens. An object which is behind, it's a virtual object. So this object is behind. Therefore, it is acting as a virtual object for the lens. Therefore, put a negative, which gives us negative of what? 10 centimeters. So subscript 1 over F equals 1 over U plus 1 over V. Where V is the final image distance. So 1 over, this one is 15, is equal to 1 over negative 10 plus 1 over V. So 1 over V will become 1 over 15 plus 1 over 10. Let us say we started. This is 2 plus what? Plus 3. That's 1 over V. So the answer is V will become 30 over what? Over 5, which gives us 60 centimeters. Then we shall now say that this image is real. Image is what? Image is real. That's the nature now. Then magnification will become magnification of A times magnification of what? Of B. But magnification is going to be out of what? U. So can we substitute? So magnification will now become magnification of A is V out of U. V is 30 divided by U. Our U is 6 times magnification of B. Magnification of B, it is V. Our V is what? Is 6 times our U. Our U is what? 10. Take a positive, not a negative. Okay? Then we shall now say this is what? This. So the answer gives us what? 3. So the image is magnified, not so? The image is what? Magnified. Then let us sketch. Let us now draw the final ray diagram. So we have this is the lens in position A. This is the lens in position B. Then this is the A. This is the lens B. All of them are converging lenses. This is object O. What this one does like this. Like that. So it is going to form the first image. The first image was here. Let us call it I prime. I prime. But since it is acting as a virtual object, we shall use dotted lines here. Like that. Then, now this is a converging lens. What it does, it converges. Even the distance, you can see that this distance from here to here is what? Is 10. Is 10. Okay? But the final image is formed at 6. The final image is 6. So that means that the final image is around here, in between. It is not beyond 10. It is below what? 10. So, here this is a converging lens. So what it does, it converges. Okay? Converges. So here we're going to converge to form the final image. Let us say the final image is there. So, and the final image is here because we got a positive answer. So this is the final image. So that's how it is done. Okay. That's number 1. Then we go to number 2. Number 2. We have another example. Number what? Number 2. Is it okay? That is example for number what? Number 2. I hope that is fine. It's okay. That's number 2. So number 2 says, a thin converging lens P of focal length. So we have a thin converging lens. So this is a thin converging lens. The focal length, this is P. Then we have a thin diverging lens. This is 2. Then they're saying that focal length here is 10. Focal length here is what? Is 15. The distance of separation they have given us what? They have given us 50 centimeters. An object is placed here at a distance. Find something is missing. A thin converging lens P of focal length 10 centimeters and thin diverging lens Q of focal length 50 centimeters are placed coaxially 50 centimeters apart. So there's something missing there. Then we say if an object is placed 12 centimeters from P, if an object is placed 12 centimeters from P, 12 centimeters from P on remote side of what? On remote side of Q. On remote side of what? Q. So can you see it here? You see? If an object is placed at 12 centimeters from P on the remote side of Q. So it is placed at 12 centimeters. So from here to here, it's 12 centimeters. So now this one forms an image here. Let us take I prime. The distance here we shall call it V prime. So we don't know where this one forms the final image. But this image formed by P will rotatively act as an object for P, sorry, for Q, and then the Q will use it as an object and forms the final image. So let us check. So action of P. Action of P. So we shall say 1 over F, 1 over U plus 1 over T, 1 over V. So this one can be 1 over 10 equals 1 over 12 plus 1 over V prime. So 1 over V prime will become 1 over 10 and that's 1 over 12. So V prime will become 60 centimeters. Now, where is that distance? Where is that 60 centimeters? So we shall now say this. Remember, this one answer what? It will become u. So action of what? Action of 2. So what is our objective distance? Our from here to here is 60. Then this is what? This is 50. So what's the remaining distance? So it will be 60 minus what? 50. But it's a battery because real objects are placed in front of the lens and not behind. You understand? The real objects are placed in front, not behind. So this will, u will become negative 10 centimeters. So using 1 over f, 1 over u plus 1 over v, it implies that 1 over f, this is the diverging lens, meaning that the focal length is negative. So focal length is what? Is negative 15 is equal to 1 over negative 10 plus 1 over v, the final image. So 1 over v will become 1 over negative 10, sorry, 1 over negative 15 plus 1 over 10. Also in start negative 2 plus 3, 1 over v. So our v becomes 30 over 1 centimeters. So meaning that image formed is what? Image is real. Because it's a positive answer, so the image is what? Is real. Then they are also asking us find the magnification. So magnification will be equal to m of p times m of what? 2, which will become m of p, it is v out of what? 60 divided by u, which is 12, times, for the case of 2, it is v over u. Our v is what? 30. Our u is what? Is 10. So this is 5 times 3, which gives us what? 15. Then we sketch the what? The diagram. We sketch the what? The diagram. So sketching, we shall have something of this nature. Shall have this. Shall have this. Okay. Then here. This is B. Then this is what? This is 2. This is what? For its axis, an object O. We have something like this. Moving down here, like that. Following the virtual what? A virtual. If forming a real image which will act as a virtual what? A virtual object for that. So this is I what? I prime. So this is a diverging. Remember, this distance is 10. But the final image is formed at 30. 30 is beyond. Not so? 30 is beyond. And remember, it is real. It is what? Real. And you know, for the case of diverging lenses, you know where the virtual image is formed. The virtual is in front of the lens. Then the real image is behind what? The lens. Then the real object is in front of the lens. Then the virtual object is behind what? The lens. Take note of those things. So we're going to diverge. Diverge is. We diverge from here. Here, we diverge. Diverge. So the image form is what? Is it? This is the final image. And that is how the ray diagram can be drawn. Now, having known that, when you have understood the concept, you can go ahead and do these numbers. You can go ahead and do these numbers. You see? You can go ahead and do this what? These numbers. I hope they are clear. I think they are clear, I hope. So you can go ahead and do those numbers. Is that okay? Yes. So do those what? Numbers. Yeah. However, I also want to mention this, that if you have rays of light which are parallel to the principal axis, they converge at what? They converge at this system. Okay? Now, if you have rays of light which are parallel to this, which are like this. Okay? They converge at F, but the point is not on principal axis, but is down. They will converge somewhere here. Let me say if you have like this. So they will converge in. If this one is F, then they will converge, the image will be formed here. So they will converge down here. Okay? They converge like that. And if this is the diverging lens, and you have the rays like this, they are what? They diverge, but they appear to be coming from where? From F. This is F. Is that okay? So I think you should not get confused when it comes to the diagrams. Because in most cases, for you to answer this question properly, then you should be knowing how to draw this ray diagram. The principle of the ray diagram should be well understood. Otherwise, you end up confusing yourself, and you end up doing things which are wrong. So please take time and go through those ray diagrams and know the principle of drawing those ray diagrams. So at the moment, I think you'll find this one also so interesting. You'll find it so easy, so simple. You just pass. However, do not cram. Just understand the action of every lens other than cramming. Please do not cram. These things are very simple. You can understand just like other people have understood before. Thank you very much.